Alright, so here's section 8.5. And so last time you learned, or before you learned what the dot product was, so here's the cross product. But we need to do a couple more do a little something beforehand, before we really learn what the cross product is. So the cross product involves calculating what is called the determinant of a 3x3 matrix. So whenever you have a matrix, usually what it's for, and you might have done some in Algebra 2, but like you have a matrix with some numbers in it. Usually they have these like corner brackets, like let's say 2, 5, 3, -1 or something like that. So that's a 2x2 matrix, right? So it has 2 rows, so 2 rows going across and 2 columns, right? And so a lot of times this comes from a system of equations. Like let's say you had 2x plus 5y equals 4, and maybe like 3x minus y equals, I don't know, 2. And so you use the coefficients to set up a matrix, and there's a whole process to it, but anyway, like a lot of times these numbers come from the coefficients of like a system of equations. And then there's more to this, but we don't have to go into that. So anyway, when you have these straight lines instead of these brackets right here, that means a determinant. So one way to calculate the determinant, there is a way in the calculator, but we can't use a calculator because we're going to have letters in ours. But one way to calculate the determinant is to do this, is to take the first 2 columns of the matrix here and repeat them on the side. 3, 1, 2, and then -2, 0, -1. So what we're going to do is we are going to multiply some numbers together here, but we're going to go across diagonals. So we're going to go across this diagonal. So 3 times 0 times 6 is 0. And we add, and we keep doing it because this is a 3x3, so we got 3 numbers. The next one with 3 numbers is this one. So -2 times -5 is 10. 10 times 2 is 20. And I add, and finally I get one more. So 4 times 1 times -1 is -4. Then I go the other way and I subtract. So when I go this way, I put minus, and then those multiply to 0, minus these 3 things multiply to 15, and then minus these 3 things multiply to -12, so I'll have a double negative. Okay, so when all is said and done, I basically add these up. So let me see. This turns into +12, so let's see, -3 and -4 make -7, so 20 minus 7 is 13. So there's a determinant. Well, I can do that same thing over here. The 2 vectors that I will be given would be these 2 vectors, but instead of having a 3rd row of numbers, I have the letters I, J, K, like your 3D coordinates, your 3D unit vectors. So we can do the same thing. We have I, 5, 5, so put that out to the side. All right, and then J, -4, 1. Okay, so we're going to do the same thing. We're going to multiply these 3 things together. So when I multiply them, though, I get 8i. So I no longer have a number there. I just have a variable. So I have 8i plus, then I do the next one. So that would be 35j plus 5k. Right. And then if I go backwards, I'm subtracting. So this will be minus a -20k minus 7i and minus a -10j. Alright, so let's clean this up. So I got 8i minus 7i, so I have 1i. So those are done. I have 35j plus 10j, so plus 45j. Those are done. And then 5 plus 20, so plus 25k. So I can have this vector. This is my cross product. That's how we do a cross product. This is my cross product. I can write it like this, or I can leave it like this. 1, 45, and 25. So this is a little bit of a harder way to do this, or is a little bit of a faster way that I'm going to show you. But here's the steps down below. Copy the first 2 columns outside, multiply the diagonals going right, and multiply the ones going left. Okay. All right. So for this next method, I need to know how to do the determinant of a 2x2 matrix. So when you have a 2x2 matrix, if you're going to do these straight lines, the determinant, you crisscross. So I multiply these 2, minus multiply these two. So it's a little bit similar to the one up there, but so 10 minus negative 18. So that comes out to what? 28. All right, so let's try this one. 28 minus 5. So 23. Okay, so that should be like a really quick thing. All right, so let's see if somebody asks you how to calculate the cross product of two vectors, two 3D vectors. You only do this with 3D vectors. So 5, negative 4, 7, and 5, 1, negative 2. So you set up yourself a matrix with I, J, K in the top, and the order matters. You have to put the first one here, and then the second vector below it. Okay, and so this is the same problem that we did earlier, so it's going to be the same answer, but I'm going to do it a little bit different way that might be a little faster for some of us. So here is our answer. So I'm going to write my answer in 3 parts. So, and this is my I, my J, and my K. All right, so what I do, if I want the answer for I, what I do is I go and I cross off in my mind the column and the row that have I in it. So look at these 4 numbers. Do their determinant. 8 minus 7. Well, 8 minus 7 is 1. So you see, I'm getting the same exact answer I got up here. Then, if I want J, I cross off the column with J and the row with J. And so I see how I have those 4 numbers. This is the most annoying one because, like, I have to split myself here. So I have these 4 numbers. So 5 times negative 2 is negative 10, all right, minus 35. So this is a negative 45. Now that's not supposed to be the answer. So what you do for the center answer is you do the opposite of this. So we're going to take the opposite, yeah, that's how you spell opposite. Sorry, the opposite, and that's going to be positive 45. Because I already know the real answer from up here. All right, and then I cross off the column with K and the row with K, and I do the determinant of those other 4 numbers. So 5 times 1 is 5 minus negative 20. So 5 minus negative 20 is 25. And there I go. I have my answer that I had here. I think this is a little bit more work. This down here, this method of crossing off the columns is a little bit easier. So you basically cross off the columns and then you do the 4 numbers left over. Okay? All right. So, there we go. So we're going to try it here. So pause the video and maybe try it right here. And I'm going to do it in a second. All right, so I want my answer. I want to cross off the column with the I. So that means I'm going to have negative 12 minus negative 3. So negative 12 plus 3 would be negative 9. I'm going to cross off the J. So that's going to be negative 30 minus nothing. So negative 30 minus nothing is negative 30, but then it's going to turn to a positive 30. And then cross off the K. I'm going to have 15 minus nothing. So it's really nice when there is a 0 there. Okay. All right. Negative 3, 2, 4, cross with that. So I'm going to go ahead and set it up. I, J, K. Negative 3, 2, 4 is first. 4, negative 1, 1 is next. All right, so do my cross product. All right, so cross this off. I get crisscross 2 minus negative 4. So that's 2 plus 4 is 6. Cross off the center. Ugh. I get 3 minus 6, negative 3 minus 16, so negative 19, but I'm going to change the sign. And for the last one, I get 3 minus 8. So 3 minus 8 is negative 5. So there's my cross product. I can write it like this, or I can write it like this in standard form. Now, the most important thing about the cross product is this. Now you can calculate the cross product of two 3D vectors. You can do that. So what is this? So you have to know this fact. The cross product of 2 vectors produces a 3rd vector. This is like the main idea for like when you do a lot of 3D stuff, like in multivariable calculus and with lines and planes and all that kind of stuff. It produces a 3rd vector that is actually orthogonal to both of the original 2 vectors. So you use this a lot in physics and all that kind of stuff. So basically what happens is when you have two vectors and you're doing the cross product, it produces a third vector that is actually perpendicular to both. So it's perpendicular to the plane that these two things are on, basically. Okay, so let's check it out. So these two vectors up here, where we calculate the cross product, how do we check if vectors are perpendicular? We dot them and see if the dot product is 0. So we're going to dot these two vectors, and we're going to dot these two vectors to prove to you that this vector is actually perpendicular to both the original vectors. Okay, so here we go. Negative 3, 2, 4, dotted with this. So let's see what we got. So we get negative 18, plus we get 38, plus negative 20. Yep, so negative 38 plus 38, 0. All right, and then here, my other vector. So it doesn't matter what order you do the dot product. So you get 24 plus negative 19 plus negative 5. So yep, 0. Okay, so that's the most important thing to know about a cross product, is it produces another vector, a third vector from the original two, that is now perpendicular to both of the original. All right, so here's some just properties of the cross product. U cross V is orthogonal to both U and V, what we're just talking about. So let me add one more thing to this. U cross V is not the same as V cross U. What will happen is it'll be the opposite. If you switch these two, if you take these ones, if you switch the rows here and do the cross product, you'll get the opposite numbers here. You'll get negative 6, negative 19, and positive 5. So it's not that big a difference, but it's important. Okay. The cross product is 0 if the vectors are scalar multiples. Well, what does it mean for vectors to be scalar multiples? It means they are parallel. So I guess if you want to prove that two 3D vectors are parallel, you could do their cross product, but it seems like a lot of work because you could just also show that they're multiples of each other. All right, now here's ones that are kind of a little strange. The cross product, the magnitude of the cross product produces the area of a parallelogram having vectors u and v as two of its sides. So if you have vector u and vector v, touched up right there at the corners, if you turn that into a parallelogram, then if you do the magnitude of the cross product, this will produce the area of this parallelogram. So we'll do that in a second. And what do you get when you have a parallelogram? Oops, that's ugly. And you divide it in half? Well, you get a triangle right here, right? So 1/2 that area would be the area of a triangle with u and v as two of the sides. All right. All right, and the order matters. Oh, I forgot that I put that already. Okay, so I want to find the area of a triangle with these vertices. So I'm just going to kind of draw it out so we can get an idea of what we're doing. I'm not graphing this in any way, but we'll just do like A, B, and C. So basically I'm trying to use this formula right here, right? I need to find vector AB, so let's find from A to B. I need to find two of them. I don't care which two, and then we'll do AC. All right, so from A to B, 2 minus 5 is negative 3. 4 minus 0 is 4, 7 minus 6 is 1. So that's the vector from A to B. From A to C, so these two, 2 minus 5 is negative 3, 6 minus 0 is 6, and 1 minus 6 is negative 5. So I'm going to do the cross product of these two vectors, that's my u and my v. I'm going to do the magnitude, and then I'm going to take half of that number. All right, so here we go. So my cross product, I, J, K. And, it doesn't really matter which one I do first here. I'm not trying to prove anything. I just need the cross product. I need the magnitude, so it's not going to matter the order, but I'll just do this one first. Negative 3, 4, 1, and negative 3, 6, negative 5. All right, so let's set it up. So cross off I get negative 20 minus 6, so negative 26. Cross off the middle. I get negative 15 minus negative, I get 15 minus negative 3. So 15 plus 3 is 18. And here, I get negative 18 minus negative 12. So negative 18 plus 12 would be negative 6. Okay, so I have to do the magnitude of this thing. Let me check those numbers, make sure I'm good. Negative 26, negative 18. Oh, that 18 in the middle. Remember, I was supposed to change the sign. I forgot to do that. Yep, the rest is good. So I need the magnitude of this thing. Square root. I'm going to take 26 and square it, take 18 and square it, and take 6 and square it. It doesn't matter if I put the negatives, they would go away anyway. So I need half of this value. So that's my area. All right, so 1/2 of, that would be the square root of 1036 units squared for area. So if we want to say a decimal for that, it's 16.1 units squared. Okay, all right, last little bit right here. Given these two vectors, we're just going to go back through and kind of summarize what we can do here. Find the angle between the two vectors. So the cosine of my angle is my dot product over my magnitudes multiplied together. So I think I'll find those things and we'll apply that formula. So A dot B, so 2 times -1. 2 times -1 is -2 plus nothing, plus -3 times -4 is 12, so that comes out to 10. My magnitude of A, 4 and 9, so the square root of 13. My magnitude of B is 1, 1, and 16, so 18. All right, so let's do our formula. Cosine of my angle is 10 over the square root of, what is 13 times 18? Let's see. So 234. All right, so pop that in your calculator, inverse cosine of that, and you will get, oh, we'll just do it here. All right, second cosine, 10 over square root of 234. Oops, don't need that. Okay, 49.2 we'll say. So that's the angle between the two 3D vectors. So remember, two vectors crossing each other, that might be the small angle. So if you wanted to find the big angle, you'd have to do 180 minus that. So if somebody asked you for the obtuse angle, you'd say, oh, well, 180 minus 49.2 would be the obtuse angle. All right, find the cross product. So we got I, J, K. A and B, so I'll just put 2, 0, -3, -1, 1, -4. All right, so cross off I get nothing minus -3, so 3. Cross off the middle, I get -8 minus 3, so -8 minus 3 is -11. I'm going to make that positive 11. The last one, I get 2 minus nothing, so 2. All right, show that the cross product is orthogonal to vector B. All right, so show that my cross product, 3, 11, 2, is perpendicular, orthogonal to B, which is -1, 1, -4. All right, so I get -3 plus 11 plus -8, and that is 0. All right, find the area of the parallelogram with A and B as two of its sides, so we're supposing A and B are like that. So remember, my formula is this. My area is the magnitude of the cross product. Well, I already have the cross product, so I need the magnitude of 3, 11, 2. So that would be the square root of 9 plus 121 plus 4. So what is that? 125 plus 9, so 134. So you could say that units squared. Okay, all right, that is it. See you later.